In this video, you will learn how to find the distance between 2 points. To appreciate how the formula for finding the distance between 2 points was arrived at, it is important for you to have a knowledge of what the Pythagoras theorem is. So, for example, if you are given the points A, 5, 3, and B, 18, 17, and you are asked to find the distance between the 2 points A, B, then you can form a right angle triangle by drawing lines from point A to where point B is, then draw from point B to intersect the line that you've drawn. So at this point, a right angle triangle has been formed. In order to find the distance between the 2 points A and B, then we can use the concept of the Pythagoras theorem, which says that when you have a right angle triangle, then the hypotenuse squared, in this case AB squared, which we are interested in finding, is the same as the opposite squared plus the adjacent squared, or the sum of the squares of the other two sides. In this triangle, the horizontal distance is 13 because we can find this by subtracting or finding the difference between 18 and 5. Or if we count the number of boxes below here, then we get 13 units. So assuming each of the box here is 1 unit. If we count vertically, we also get the distance from 3 to 17, which is going to be the difference between 17 and 3, in this case 14. So if we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, which is 14 units. Using the concept of Pythagoras theorem, then it means that AB squared, which is the hypotenuse squared, is equal to the sum of the squares of the other two sides. So in this case, 18 minus 5 squared plus 17 minus 3 squared. So this simplifies to AB squared equal to 13 squared plus 14 squared. So when we take the square roots of both sides, then AB is equal to 13 squared plus 14 squared, meaning AB is equal to 19.1049731.7 units. Using this concept, then we can derive a general rule for finding the distance between 2 points. So let's say that we are given the 2 points A with coordinates x1, y1, and B with coordinates x2, y2. We are asked to find the distance between these two lines, A and B. Then, using the concept of Pythagoras, we can form a right angle triangle. And this horizontal distance is going to be the difference between the x values. So, x2 minus x1. And the vertical distance is going to be the difference between the y coordinates, which is going to be y2 minus y1. This implies that AB squared is equal to x2 minus x1 all squared plus y2 minus y1 all squared. Addition is commutative. So if you decide to state this first before the y2 minus y1 squared, you are still correct. So if you state that x2 minus x1 all squared plus y2 minus y1 all squared is still correct. So if we want to make AB the subject, then we can take square root of both sides, and AB is equal to y2 minus square root of y2 minus y1 squared plus x2 minus x1 squared. So this becomes the general rule used in finding the distance between 2 points. So it is simply the square root of the difference between the y coordinates squared plus the difference between the x coordinates squared. For example, if you are asked to find the distance between the 2 points A, 2, -3, and B, 4, 2, what we have to remember is our general formula for finding the distance between 2 points. So square root of Now, in order not to confuse yourself, it is advisable you label the coordinates of the point. So this is x1, y1, and this is x2, y2. So the general formula for finding the distance between 2 points is square root of x2 minus x1 all squared plus y2 minus y1 all squared. So when I substitute these values into the general formula, then I have AB is equal to square root of x2 is 4, so 4 minus x1, which is 2, all squared, plus y2 in this case is 2 minus y1, which is negative 3. So you have to be careful here. So 2 minus negative 3 all squared. So this simplifies to AB equal to the square root of 4 minus 2 is 2. So 2 squared plus 2 minus negative 3 is positive 5. So 5 squared. So this becomes AB equal to the square root of 4 plus 25. So AB is equal to the square root of 29. And that's our answer. But in case you are required to leave your answer in decimals, then you type this into your calculator and you get the answer in decimals. Let's look at our next example. So let's say we are also asked to find the distance between the points A, B with coordinates 4, 3, and B, -1, -1. As usual, we have to remember our general formula. AB is equal to square root of x2 minus x1 all squared plus y2 minus y1 all squared. Now, just like I mentioned before, in order not to confuse myself, I'll label the coordinates x1, y1, so x2, y2. So I'll substitute this into my general rule, and I have square root of the x2 in this question is -1, so -1 minus x1, which is 4, so -4, plus y2 is also -1, so -1 minus y1, which is 3. So our AB is equal to square root of -1 minus 4 is -5. So here we have to be careful. Sorry, I add the squares here. So here we have to be careful not to write this as -5 squared, because this is not the same as, into bracket, -5 all squared. So -5 all squared plus now -4 all squared, because -1 minus 3 is -4. So when we simplify this, then we have our expression as AB equal to square root of 25 plus 16. So AB is equal to the square root of 41. That is 25 plus 16. So just like I said, this is our answer. But in case the question says we should leave it in decimal, to a given number of decimal places or significant figures, depending on how we want to leave our answers, then we can type this into the calculator and we get our answer in decimals. So basically, that's how to find the distance between two given points. So now let's look at this example, which looks a bit different from what the two examples we've discussed so far. In this question, it says that the points P, Q, and R form a triangle PQR. We should use the distance formula to classify the triangle as equilateral, isosceles, or scalene. So I'm going to give a rough sketch of how the triangle may look like. So if this is my Cartesian plane, So I have my X and the Y axis. So point P, 1, 0, probably around this side. So 1, 0. So this is point P. Q, 3, 1. So 3 and 1 here. So this is our Q. And R, -3 around this side. So -3 on the X axis and 8 on the Y axis. So a bit around here. Good. So this becomes our R. So if I join this, then a triangle is formed. So we are asked to classify this triangle as equilateral, isosceles, or scalene. At this point, because we've learned how to find the distance between 2 points, I will allow you to find the distance between the points. So we have to know the distance between PR, PQ, and QR. So we have to know the distance between these points. So I'm just allowing you to find the answers to this. Pause the video and done finding the distances, then you can now continue to play it to see the answers. So if you do this well, then the point PR will have a distance. I mean, the distance PR will be 80, root 80. PQ will be root 5, and QR will be root 85. So what is an equilateral triangle? All the sides are equal, but in this case, the distances we found show that the sides are not equal, so it's not equilateral. Isosceles means that 2 sides of the triangle should be equal, but in this case, we don't have 2 of the sides being equal. So it means that in conclusion, this triangle is a scalene triangle. Now, the next question says that we should determine whether the triangle is a right triangle. So to answer this, then we have to use the converse of the Pythagoras theorem. So we have to use the converse of the Pythagoras theorem, because if it is a right angle triangle, then the square of the longest side should be equal to the sum of the squares of the other 2 sides. So in this case, if it were a right angle triangle, then the sum of the squares of the 2 shortest sides of the triangle should be equal to the square of the longest side. So in this case, we can see that the longest side is QR based on the distance, and that is QR. So it means that if this is a right angle triangle, then square root of 80 squared plus square root of 5 squared should be the same as square of root 85. So if we do this, square root of 80 squared is 80 plus square root of 5 squared is 5, which is equal to 85. So we can see that square root of 85 squared is also 85. So since the squares or the sum of the squares of the other 2 sides, which is this plus this, is the same as the square of this side, then it means that this is a right angled triangle. So, and that's how we determine if a shape is a right angled triangle or not, by using the converse of the Pythagoras theorem. Thank you very much for watching this video. So in this video, you've learned how to find the distance between 2 points using the general formula for finding distance between 2 points. In the next video, I'll be treating how to find the midpoint between 2 given points.